So now we're on to example 6. So in this question, it wants us to solve for an angle given its approximate sine, cos, or tan value. So when you're dealing with an approximate angle, that means you're going to have to do quite a bit of reasoning to determine this one. Now, here we're given that cos angle equals negative 0.6753, where the angle is between 0 and 360. Determine the measure of the angle to the nearest tenth of a degree. So in our last video, hopefully you watched, we were given something where we could determine that this has to do with a special triangle. In these cases, we are not dealing with a special triangle. You're given some decimal value that is the cos ratio. These questions can be tough because you have to really keep track of what you know and what you don't know. So in this case, what do we know? Note the restrictions, that this can exist between 0 and 360. So the first thing I want to determine is, you know what? Where can my cos value actually be negative? Am I dealing with one solution or two? So recall cast and determine where is cos negative. Cos is negative in quadrant 2 and quadrant 3 because here all of them are positive, and this one cos is the only one that's negative, positive. So we can actually get rid of these two quadrants, okay, because cos is positive. So we have two potential areas. We have cos here, that could be positive, and cos here that could be, negative, and cos here that could be negative. So let's extend a terminal arm, even though we don't know much about it, and start figuring this out. So we have two possible solutions that would make cos angle equal negative 0.6753. You have an angle that is formed here. So I'm going to call this the standard angle 1. And then I'm going to draw another Cartesian plane just to keep things organized. And this one would be our standard angle 2. That could work. Now let's determine what these angles are. Now, how are we going to do that? So in Math 10C, we learned that if we wanted to solve for an angle given a ratio, we're going to take the inverse. So that's what I'm going to do here. I'm going to ask myself, I know that cos angle equals negative 0.6753. To solve this angle, I'm going to take the inverse of it. And let's see what it gives us. So in inverse cos, so second cos, negative 0.6753. So we can see here that that gives us 132.4 degrees. So at this point, we know that this angle is 132.4 degrees. Now, let's determine where that's found. So here we have 0, 90, 180, 270, and 360 degrees. Now, 132.4 degrees is not going to be found here because that's over 180. We would be found, we're talking about this terminal arm here. So 0, 90, 180, 270, 360. So hopefully you can see that 132.4 degrees would roughly be around here. It's between 90 and 180. So we have actually just found our first standard angle, 132.4 degrees. But good thing we noted what our restrictions was to begin with, because there's another possible angle here. And how are we going to find that? Well, a special thing about angles that share a ratio is that they share reference angles. So the reference angle found here will be the same reference angle for this standard angle. So now we got to ask ourselves, what's the reference angle here? and that will be shared here. So let's find the reference angle. Find reference angle. How am I going to find the reference angle here? Well, remember, from here, 0 to 180, that's 180 degrees. If I take away my standard angle 1, I'm going to be left with the reference angle. So my reference angle will be 180 degrees minus 132.4 degrees. So now we have been able to solve for our reference angle once we plug this into our calculator. So that's 47.6 degrees. Now, we have the ability to determine our second reference angle. So standard angle 2. Standard angle 2 can be found because now we know this reference angle. Again, they share it. This is that's 47.6 degrees. This is 47.6 degrees. So this standard angle 2 will be found by adding 180, so this angle here, plus the reference angle. So standard angle 2 will be 180 degrees plus 47.6 degrees. And that will give me 180 plus 47.6. That gives me 227.6 degrees. So there's my two standard angles. Now let's check my answer here. It's useful to check. So if I plug in cos angle plug in these standard angles for my angle, I should get this, or roughly about it. Remember, we did round this, so maybe it'd be a decimal off. So cos 132.4. We can see here negative 0.6753, negative 0.6743. So we're only a decimal off there. And again, why is that? That's because we rounded. Okay. Let's plug in cos 227.6. And again, that gives us negative 0.6743. This gives us negative 0.6753. So we're a decimal off because, again, we rounded these values. So hopefully that made sense. I would definitely go back and maybe try this one again without the video, and then reference the video if you need some help. The biggest thing to get out of this is remembering that when you have standard angles that share the same ratio, that's because they share the same reference angle. So you can go on and give this one a shot for your turn. So determine the measure of the angle to the nearest degree given sine angle equals negative 0.8090, where the angle is between 0 and 360 degrees. So again, let's first note our restrictions and where this angle could possibly exist. Recall that we're always talking about the standard angle that exists within this ratio here. So our sine ratio is negative. If we throw out our cast rule, where is sine positive? Sine is positive in quadrant 1, and sine is positive in quadrant 2. So we can ignore these two quadrants. So now we're going to focus on quadrant 3 and quadrant 4. So my first step is to draw these two cases out. So my case 1 will be quadrant 3, and my case 2 will be quadrant 4. Let's note all of our quadrantal angles, just so we have those written down for ourselves. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Again, ignoring the quadrant 1 and quadrant 2. My first case is a standard angle that exists in quadrant 3. My second case is a terminal angle that exists in quadrant 4. Let's call this angle standard angle 1. Let's call this angle standard angle 2. So now we have the ability to see here, we have two possible solutions that exist within our restriction that can cause sine angle to equal this number here. Now in this case, we are going to ask ourselves, how do I solve for this angle? How do I solve for this angle? Well, again, let's plug in the value. Let's use our Math 10C rules. And our first step will say sine angle equals negative 0.8090. Now, the biggest thing to recall is that your calculator is not as smart as yourself. So when we take the inverse of this ratio, let's make sure we apply the negative value here. We have to be aware of a few things. So what are we going to be aware of here? We're going to be aware that our calculator only is going to spit out one solution. And that solution may be one of these answers, or may actually be a negative angle, which is not what we're wondering about. So let's plug this in. Sine negative, so the inverse of sine, negative 0.8090. Now we can see here something kind of strange. We get negative 53.998. And this is because your calculator tries to find the nearest angle that makes this work. So negative 53.998 degrees. What are we supposed to do with that? So the nearest angle that causes sine to be this ratio is found in quadrant 4. What your calculator has done is it has went clockwise. Remember, clockwise angles are negative. So that's something we learned at the very beginning of this chapter. So this angle here, this standard angle it's giving us is negative 53.998 degrees. Now recall what we talked about in the last example. Any standard angle put into here share a reference angle. So this actually gives us something to work with. Because the reference angle, remember, reference angles are always positive. Always positive. So what does that mean for this ratio? Or sorry, for this standard angle? Well, the standard angle here is the clockwise angle that's given. And in this case, that means our reference angle also equals 53.998 degrees. So we now have a reference angle that causes and is related to this sine ratio. And remember, every standard angle that we plug into this angle that gives us this ratio share the reference angle. So this reference angle, we now have a reference angle. And these two things have reference angles here, these two angles. And we now know that reference angle. So even though this isn't one of our solutions, this has helped us find the reference angle to our solutions. This will only happen when you're dealing with negative sine ratios, because your calculator doesn't want to go all the way to the third quadrant and give you that standard angle, which would be this solution here. It wants to give you the easiest solution that it can find, which is just a negative small angle. So again, this angle here, this standard angle, has this reference angle, and all the values that share that reference angle, all the standard angles, are the solutions here. So now we have found a very useful value. This reference angle here, which is 53.998 degrees. Because remember, reference angles are always positive. And we now know that this reference angle here is 53.998. So reference angles are a very powerful thing. And from there, we can actually solve our solutions here. So we can solve for the standard angle here. We can solve for the standard angle here. So our standard angle 1, it's the addition of 180 degrees plus our 53.998 degrees. So 180 degrees plus 53.998 degrees. So our standard angle 1, let's plug into our calculator, 180 plus 53.998. That gives us 233.998 degrees. And we're going to round that to the nearest tenth. So 234, and it's actually going to be 0.0. Okay, because our value here, our 9, rounds this 9 up to a 10, which rounds this up to a 4. So 234. So there's our first standard angle. We can find this standard angle 2, by understanding that a full rotation is 360. If we take away this reference angle, we're left with our standard angle. So 360 degrees minus 53.998 degrees. 360 degrees minus 53.998 degrees. So that gives us 306.0 degrees. So there are our two standard angles. Now let's plug it in and check. So again, now we know the standard angles that create this ratio. Let's make sure that it's correct. So sine 234, again, we rounded, so it might be a bit different numbers, but we can see that they're almost the exact same. Negative 0.8090, negative 0.8090. Sine 306, we can see gives us the same value. So we have been able to check our solutions. So always note what your restrictions are, plug it into your calculator, and reason through your solution. What have I been given by my calculator? Your calculator gives you one standard angle. That is the smallest angle it can achieve. So when you're dealing with negative sine values, it's going to give you a negative value because it wants to give you the smallest angle that it can think of. So it'll actually go clockwise. So that was a really good example to go through. And if you have any questions, please come ask. Have a great day.